Hey guys, today we're doing rational expressions. The thing to remember with rational expressions is that those are fractions, and fractions are just division problems. So anytime you see a fraction bar, you want to think of that just means I'm going to divide the top by the bottom. All right, so as we get started, remember the rules for fractions, which is if you are adding fractions or subtracting fractions, you need the base or the denominator to be the same for the two terms. If you're multiplying, you do not need the base to be the same, okay? And again, this is just what I said at the beginning. Remember, rational expressions with variables are just fractions. They follow the same rules of fractions with regarding to simplifying and performing operations. When you're dealing with rational expressions, we're often going to start with factoring. We're going to start with putting the polynomial in descending order, just like we did in 1.3 and 1.4. And then we are going to factor it if possible. Once you have factored it, you're going to see if you have any factors that are common to both the numerator and the denominator, the top and the bottom, and you will cancel those out, and that will be your simplified form of that rational expression. That will be how you finish the problem. All right, so for this warm-up, it says use prime factorization to simplify. Factorization is just factoring, so changing 8 into the terms that 8 is able to be divided by, right? So 8 can become 4 times 2, or 8 can become 2 times 2 times 2, right? The, that's a fact. Those are both factorizations of 8. So 4 and 2 is one factorization of 8, and then 2 times 2 times 2 is another factorization of 8. Prime means all of your factors are prime numbers. So you've got it into the smallest numbers possible. So the prime factorization of 8 would actually be 2 times 2 times 2, because when you just do 2 and 4, you can factor 4 again. 2, 2, and 2, those are all prime. 2 is a prime number, so that's the prime factorization of 8. Good. So we'll factor 8xy to the fifth is going to be 2 times 2 times 2. There's one x and there are 5 y's, so I'm going to write them all out. Y to the fifth just means y times itself 5 times. Do I have enough space? Kind of. Good. On the bottom, we've got 4 is 2 times 2. X to the third means we're going to do 3 x's. And then y to the fourth means we're going to do 4 y's. Y times itself 4 times. Good? So we've put it into its factored form. Now we simplify. How do you simplify with fractions? You cancel anything that is common to both the numerator and the denominator. So that pair of 2's you can factor out. That pair of 2's can be factored out. One pair of x's. And 4 y's. All right, and then you just look at what is remaining. On the top, we have a 2 and a y. On the bottom, we have 2 x's. So the prime factorization of 8xy to the fifth divided by 4x to the third y to the fourth is 2y over x squared. Good? Okay. So how do we simplify a rational expression containing polynomials? We're just going to take the polynomial and we're going to factor it as much as possible. And then we're going to take any terms that are common to both the top and the bottom. We're going to remove them. So just like that, except in the case of a polynomial, the simplified form might be 2 binomials multiplied by each other. And then we will cancel out any binomials that are exactly the same on the top and the bottom. All right? Okay. Here is a mistake. All right? This is what we need to avoid when doing this. 3x minus 7 divided by x squared plus 14 becomes 3 minus 1 over x plus 2. So ignoring this part, how did we get from 3x minus 7 to 3 minus 1? X squared plus 14 to x plus 2. It looks like what we did was we took 3 times x divided by x times x, we factored out the x, right? And then we took -7 divided by 14, which is 7 times 2, and we factored out the 7, right? And then we got -1 over 2, and here we got 3 over x, right? So then that's 3 over x minus 1 divided by 2. That is what you do not want to do because you didn't treat this whole thing like a single term. So because it's a polynomial and you can't combine any like terms, you have to treat that as a single term. Okay, so we can't just say 3x can be 3x and x squared can be simplified, and 7, -7 and 14 can be simplified. It cannot be done like that. You need to keep it as one term. Keep it as one term. Okay. The core mistake is not treating a binomial as a term that cannot be split into separate parts at the add-subtract point. So we're not going to treat them as separate terms just because there's a sign between them, a minus sign or a plus sign between them. We are not going to do that. We're going to treat it as an entire term. If we look at that as an entire term on the top and an entire term on the bottom, we want to look, see, can I factor anything out of 3x minus 7? No. Can I factor anything out of x squared plus 14? No. So it's done. This cannot be simplified. You can just leave it as is. Okay? So that's what not to do. Now let's talk about what to do. First of all, put your polynomial in descending order before factoring. Notice that the x is in front of the constant, the x squared is in front of the constant. You just want to put them in descending order like we did in 1.3, okay? If your leading coefficient is a -1, factor out a negative greatest common factor. Good. And then all we're doing is simplifying. Just like we simplified this to this, we're just going to make it simpler. You don't need to solve for x or solve for y. We're just making it as simple as possible and leaving it most likely as a fraction. Sound good? All right, so for number 4, we have the binomial y plus 8 multiplied by the binomial y minus 2 divided by y minus 2 times the binomial y plus 6. This binomial is common to both the numerator and the denominator, so it can be eliminated. And our final answer is y plus 8 divided by y plus 6. Again, don't say y divided by y is now 1, and that 8 divided by 6 is 4 divided by 3. So that's not what we're doing. It doesn't become 1 plus 4 over 1 plus 3. You stop here because that's an entire term. Just like this was an entire term, and that's why we could cancel it. So we are finished right there. For number 5, you just want to look at it. 15x squared plus 10x divided by 15x. What can we do? You are welcome to, if this is how you've learned it in other classes, 15x squared over 15x plus 10x over 15x. You can solve it like that if you would like. Good. And then just simplify 15x squared divided by 15x. What do you get? 10x divided by 15x. What do you get? You can do it like that. Or you can try to factor terms out of the top and the bottom. All right. So we're going to simplify by factoring. Here I have copied it down so that I have a little bit more space. 15x squared plus 10x. What do both of those, what do both of those have in common? You can divide both 15 and 10 by 5. And then x squared and x, you can factor out an x. So I'm going to factor out a 5x from the top. 15x squared divided by 5x is 3x, right? And then 10x divided by 5x is 2. Why? Because 15x squared plus 10x 15 divided by 5, 15 becomes 5 times 3, x squared becomes x times x, and that was all over 5x. So I can cancel out that and that. I'm left with the 3x, right? And then plus 10x, and again, you're dividing it by 5x. Becomes 2 times 5 times x over 5 times x. What can I cancel? I can cancel the 5 and the x. So that's how I got the 3, the 3x, and the 2. Good. So that's just the top. I factored out the 5x and put it in front. Now for the 15x squared, what can I factor out of 15x squared that would help me? Can I factor out a 3x plus 2? No, but I can factor out a 5x so that I can cancel them. 15x squared divided by 5x squared is going to be 3x. I didn't copy that right. That doesn't have an x. All right, so if I factor out a 5x, I just get a 3. So now I have, I'm going to write it again, 5x times 3x plus 2 over 5x times 3. What can I cancel? I can cancel the 5x, and my final answer is 3x plus 2 over 3. Because I canceled, or I factored out 5x from the top and 5x from the bottom. How I would do it if I had separated it into two factors is 15 and 15, right? 15 and 15 become 1. X squared divided by x is just x. And then here we have 10x divided by 15x. 10 becomes 5 times 2. 15 becomes 5 times 3. So I'm going to say 1x plus 2 thirds. Notice I have two different answers. I have 3x plus 2 divided by 3, or I have 1x plus 2 thirds. I'll show you that again. The other way to solve it is 15x squared divided by 15x plus 10x divided by 15x. So instead of keeping them all as one fraction, I split it into two fractions and I put the denominator as the denominator of each fraction. Now 15x squared divided by 15. 15 divided by 15 just leaves me with 1. X squared divided by x just leaves me with 1x, right? Now for that second part, 10x divided by 15x. 10 is 5 times 2 times x. 15 is 5 times 3 times x. What can I cancel? The 5 and the x, and I get 2 thirds. 1x plus 2 thirds. Sorry, I should have. So there's that 1x plus 5 times 2x divided by 5 times 3x equals that same 1x plus, canceled out the 5, canceled out the x, got left with 2 over 3. Why do I have two different answers? 1x plus 2 thirds and 3x plus 2 over 3, because 3x plus 2 over 3 is the same as 3x over 3 plus 2 over 3, which simplifies to x plus 2 over 3. So there are just two different ways to write it. You can write it as 1x plus 2 over 3, or 3x plus 2 all over 3. Same answer. The point is you're just trying to factor something out so that you can cancel it. If it's easier for you to do it each term at a time, that's fine. But it's good to practice factoring something out and then completely canceling it. Number 6 is just 24 over 3m minus 12. Let's take 24 and put it into its prime factorization. If it helps, if you want to save time, you're welcome to Google what the prime factorization would be, but basically you're making a factor tree of 24. You're saying, that could be 6 and 4, that could be 12 and 2, whatever comes to mind, right? What happens to 6? 6 becomes 3 times 2, 4 becomes 2 times 2. So the prime factorization of 24 is 3 times 2 times 2 times 2. Down here, what's the prime factorization of 3m? It would just be 3 times m. What's the prime factorization of negative 12? It's just going to be negative 3 times 2 times 2. Why? Because 12 is 3 divided by, 3 times 4, and 4 is 2 times 2. All right, we're not just going to cancel. I'm going to leave it like this on the top. And on the bottom, I'm going to say, I can take out a 3. Not a negative 3, but just a 3. Good. Now I'm sure that I can take out the 3 from the top and the bottom. So on the top, I have 8. On the bottom, I have m minus 4 because I canceled out the 3. Okay. Again, if you wanted to, you could do 24 divided by 3m minus 24 divided by 12. It's not minus 12 because the minus is right here. Good. 24 divided by 3 is just 8 over m. And then minus 24 divided by 12 is 2. Those are the same answer. 8 over m minus 2 is the same as 8 divided by m minus 4. Because if I was to separate it out, that would become 8 over m minus 8 over 4, and 8 divided by 4 is 2. So this is a little bit more, whichever one you like. Either one that you put into XYZ will work. That version or that version. I think this version's a little bit easier, but if you're used to this version, you can do that version too. I hope I'm not confusing you by adding versions. But 6 is just 8 divided by m minus 4. Number 7, what can we factor out of 4x minus 8? We can factor out a 4, right? 4x divided by 4 is just going to leave me with x. Negative 8 divided by 4 is going to leave me with a negative 2. X squared minus 4. Is there anything I can factor out? There's nothing I can factor out that is a greatest common factor, right? But I can do the difference of two perfect squares, right? What's the formula for the difference of squares? A squared minus b squared equals a plus b times a minus b, right? Here we have x squared and 4. So that means a squared is x squared, which means a is x, right? If I take the square root of x squared, I just get x. If I take the square root of a, I just get a. B squared was 4. And so b is just 2 because the square root of 4 is 2. So that means we can say that x squared minus 4 is equal to x plus 2 times x minus 2. So there was no greatest common factor in order to factor the bottom, but we can factor it with the rule for the difference of two perfect squares. And what we will get is 4 times x minus 2 on the top divided by x plus 2 times x minus 2 on the bottom. Good. That is the factored form. Now you want to look at the top, look at the bottom. What can I cancel out? Cancel out the x minus 2. So we've got 4 divided by x plus 2 for number 7. All right, number 8 is now a trinomial. We want to take both of those trinomials. I think we're going to be able to factor them into two binomials, and then we will be able to cancel out one of the binomials. All right, so let's just treat the top as something we need to factor. Y squared plus 13y plus 40. If we're using the AC method, that means we need two terms that will multiply to equal 40 and that will add to equal 13. They're both positive, so we're just going to stick with the positive ones. We could say 4 times 10, right? Just whatever's coming off the top of my head. 2 times 20. 5 times 8, right? 5 times 8 is 40, and then if we come over here, 4 plus 10 doesn't equal 13, 2 plus 20 doesn't equal 13, but 5 plus 8 does equal 13. So y squared plus 13y plus 40 becomes y plus 5 times y plus 8. Why? Because we found two terms, 5 and 8, that multiply to equal your C and that add to equal your B. You can even go back and do FOIL method. Y times y is y squared. Y times 8 is 8y. 5 times y is 5y. 8 times 5 is 40. 8y and 5y is 13y. So you can make sure that you did it correctly by reversing it again. So we factored it, then we put it into the unfactored form just to make sure it still matches. So our top, instead of having y squared plus 13y plus 40, now we have y plus 5 times y plus 8. Good. Now let's look at that bottom term, that bottom polynomial of 3 terms, I should say. We've got y squared. We're just going to do the exact same thing. Y squared plus 15y plus 56. We use the AC method. So we want two terms that multiply to equal 56 and that add to equal 15. If you want to just Google what are the factors of 56, that's perfectly fine. Save yourself some time. What would it be? All right, I'll just start with 56 divided by 2 is 28. 56 divided by 3 doesn't work. 56 divided by 4 is 14. Those aren't going to be adding to 15 yet, right? 56 divided by 8 is 7. Now let's see. 28 plus 2, 14 plus 4, 8 plus 7. Do any of those equal 15? Yes. 8 and 7 multiply to get 56, add to equal 15. That means that y squared plus 13y plus 40 divided by y squared plus 15y plus 56 becomes y plus 5 times y plus 8 divided by y plus 8 times y plus 7. So that came from there. That came from up there. Now we're just going to cancel any binomial common to the numerator and the denominator. In this case, it's y plus 8. So our final answer for number 8 is y plus 5 is what remained on the top. Y plus 7 is what remained on the bottom. And you're done. Good. All right, for number 9, remember that we want to put it in descending order of your exponent before you start factoring or trying to simplify further, okay? Here we have 8 minus m. That's not in descending order. M minus 8 is okay. That's already in descending order. 8 minus m, we actually want to switch those, right? So it will be m first, 8 second. However, should that be a plus or a minus sign right there? This is where we have to be really careful. So remember that the term is either negative or positive based on whether there is a plus or a minus sign in front of it. So the 8 does not have a negative sign in front of it. That means we're going to put a plus right here. However, that m has a negative sign in front of it. So we're going to put a negative sign in front of the m. Be very careful when you're just moving things around like that and you have a minus sign. Make sure the minus sign moves with the term it is in front of. Okay, that 8 is not a negative, but the m is a negative. So that is now in descending order. Can we simplify negative m plus 8 divided by m minus 8? Well, they look like they could almost be simplified, right? To the number 1. It looks like you could take, it looks like almost the same term, right? Here we took out y plus 8 because it was common to the top and the bottom. This is m plus 8, but it's a negative m plus 8 divided by m minus 8. So it would work, but the signs are messed up. The signs don't match, right? What is the rule we saw? Tip number 2, if the leading coefficient is a negative, factor out a negative greatest common factor. We're going to use that rule right now. If the leading coefficient has a negative in front of it, factor out a negative greatest common factor. That means I'm going to take this and I'm going to factor out a negative 1. Negative m divided by negative 1 is a positive m. Positive 8 divided by negative 1 is a negative 8. Right? So I took negative m plus 8 and I factored out a negative 1. Negative m, and I put that out in front. Negative m divided by negative 1 is a positive m. Positive 8 divided by negative 1, if you put it into a calculator, gives you negative 8. That's how I found that. Okay? I factored out the negative 1 and I put it out in front. Now what do we have? We have 2 binomials that we can cancel. What are we left with? We are left with a negative 1. So the answer to number 9 is negative 1. We had to factor out the negative 1 so that we could cancel the binomials because they were the same then. We got negative 1. They're asking us to do the same thing here for number 10. We have 4 minus x squared divided by x squared plus 7x minus 18. This is not in descending order yet. The 4 does not have a minus sign in front of it, so that's a positive 4. The x squared has a minus sign in front of it, so what it is negative x squared plus 4 divided by x squared plus 7x minus 18. Good? All right, remember, if your leading coefficient has a negative sign, that's like there's a negative 1 in front of it, factor out that negative 1, or a negative greatest common factor. Right, so I wrote it down. I'm going to factor out a -1 and put it out in front. Negative x squared divided by -1 gives me a positive x squared. Positive 4 divided by a -1 gives me a -4. So that's the factored form of the top. Well, that's a positive form of the top. I factored out a -1. Now let's factor out x squared minus 4. What do we know about x squared minus 4? That is the difference of two perfect squares. So we're going to say x squared minus 4 is the same as x plus 2 times x minus 2. Why? Because we take the square root of the first term, the square root of x squared is x, and we take the square root of the second term without the minus sign, the square root of 4 is 2. Then we just put those in to the formula we've been working on since in previous assignments. Good. So x squared minus 4 is in fact x plus 2 times x minus 2. On the bottom, we have x squared plus 7x minus 18. Let's use the AC method. It needs to multiply to equal -18. It needs to add to equal +7. So what are the factors of -18? -18 means you need one term to be positive, one term to be negative. So it could be 1 and 18, right? It's a +7. So what I'm going to do is I'm going to make the bigger of the two terms into the positive one, right? So -1, +18. Why? Because when I add -1 and 18, I still get a positive, right? That would be +17 when I add them. Here we have -2 and 9, right? 9 minus 2 is 7, so it looks like we found it, right? -3 and 6. 6 minus 3 would be 3, and I think that's it. So it's going to be -2 and +9. When I multiply them, I get -18. When I add them, I get +7. X minus 2, x plus 9. Good. All right, what is common to both the top and the bottom? The x minus 2. So my final answer for number 10 is -1 times x plus 2 divided by x plus 9. So you can either leave it like that, or you can say, you can distribute that -1 back and say it's -x minus 2 over x plus 9. Either one of these would be the simplified form of that rational expression. Okay, after number 10, we're going to move on to multiplying operations, okay? So they're asking you to perform the indicated operation and then simplify the result, leave the answer in factored form. Remember with fractions that what we want to do when we're multiplying them is you just multiply straight across. So if I had 2/5 times 1/2, all I would do is I would say 2 times 1 is 2, 5 times 2 is 10. That's just 2/10, which simplifies to 1/5. Good? So you're just multiplying straight across. 2 times 1 is 2, 5 times 2 is 10. Here we want to multiply straight across and then simplify the result and factor the answer. Good? So I'm going to copy this down. I'm going to multiply straight across. When you're multiplying, I use parentheses because we're multiplying the 5x times the 6x and the 3. Okay? So that becomes 5x times the binomial 6x plus 3. Down here, I'm going to put the 5 in front just because it's the monomial. 5 times 10x plus 5. Now, I don't see anything I can factor, right? Maybe a 5. Yeah. 5 times x times over 5 times. So if you do see something that's common to the top and the bottom, you can cancel it right now. Or not, okay? That'll just make your terms a little bit smaller, which might make it easier to work with. So then we cancel the 5. We have x times 6x plus 3 divided by 10x plus 5. Guess I don't need the parentheses anymore. I'm going to distribute that x to the 6 and to the 3. 6x squared plus 3x divided by 10x plus 5. Now, this is a binomial, remember, keep it. You put it in parentheses just to remember that we're not taking 6x squared and dividing it by 10x. We're not doing that. Never do that, okay? But do look at 6x squared plus 3x and say, what can I take out of 6x squared and 3x? Right? I can divide them both by 3x, which would give me 6 divided by 3 is 2. X squared divided by x is 2x. That was positive. 3x divided by 3x is just 1, right? See what I did there? So I took 6x squared plus 3x. I said I can take 3x out of each of those. If I take the 3x out of the 6x squared, I get 2x. And if I take 3x out of 3x, I just get 1. Good. Down here, 10x plus 5. What can I divide both 10x and 5 by? I can divide them both by 5. So instead of forgetting to put the term I'm dividing by, I'm going to lead with the term I'm dividing by. 10x divided by 5 is 2x, and 5 divided by 5 is 1. Good. So I just simplified those. Now I can cancel out the 2x plus 1. My final answer is 3x divided by 5 for number 11. Good. All right, for number 12, if you have a polynomial before you multiply, what I would recommend is simplifying that polynomial and then multiplying. Remember, multiplying just means 2 times 1, right? So you could even just say 5x times 6x plus 3 could have been 5x times 6x plus 3 over 5 times 10x plus 5, right? So if we can get this simplified before we multiply, then we'll have 2 binomials here, maybe 2 binomials here, maybe 2 binomials here, maybe factor something out right here. Okay, so let's start with 10x squared minus 3x minus 4. And what I want to do, even though that's a big A, is I want to factor this into a pair. Okay. For the AC method, we need 2 numbers that multiply to equal A times C, which is negative 40, and that add to equal AB, which is negative 3. What 2 terms multiply to equal negative 40 and add to equal negative 3? Well, we've got 4 and 10, right? Negative 10, positive 4. Maybe I'll do a different color. Negative 10, positive 4, negative 5. Well, positive 5, negative 8, negative 20, positive 2, right? Numbers like that. Do any of those add to negative 3? That does not add to negative 3. That does add to negative 3. So we're going to take negative 3x and change it to positive 5x and negative 8x so that we can do factor by grouping. We'll just skip it down to here. Now we have 10x squared. Instead of minus 3x, I'm going to say minus 8x plus 5x minus 4. So I kept that one the same, kept the first term the same, and then negative 3x became negative 8x plus 5x so that I could factor by grouping. And I picked it because it multiplies to negative 40, which is 10 times negative 4, and it adds to negative 3. Good. You can switch those around if you want. You can put the 10 with the 5 and the 8 with the 4 if you want. Now, just looking at these two, what can I divide out? I can divide out a 2x, right? So now I have 2x times 10x squared divided by 2x is 5x. Negative 8x divided by 2x is a negative 4. Good. Here we have a positive 5x minus 4. If this is a positive, you always want to make the term you're dividing out into a positive. 5x and negative 4 don't really have anything in common, right? So I'm just going to say positive 1. You can use 1 as the factor you're factoring out if it doesn't have anything else in common. 5 divided by 1 is just 5x. Negative 4 divided by 1 is still negative 4. But we can see down here that it still works because we can factor out the 5x minus 4 from both. And we are left with 2x plus 1. So 10x squared minus 3x minus 4 becomes 5x minus 4 times 2x plus 1. Let's rewrite that right here. Okay, that became that. Now let's look at the bottom of that same fraction. You can do whichever one you want. So that was the numerator of the first term. Now I'm going to do the denominator of that first term. 5x squared minus x minus 4. We're going to do the AC method again. So you want two terms that multiply to equal negative 4 times 5, which is a negative 20, and that add to equal negative 1, because there's just a 1 in front of that x, right? Multiply to equal a times c, add to equal b. Now, what two numbers multiply to equal negative 20, but add to equal negative 1? Maybe negative 20 and 1, negative 10 and 2, negative 5 and 4, right? Because there's some factors of 20. Do any of them add to equal negative 1? That would be negative 19. That would be negative 9. But this would be negative 1. Negative 5 and positive 4. So 5x squared minus x minus 4 becomes, leave that first term the same, minus 5x plus 4x minus 1. Good. So that stayed the same. That stayed the same. That negative x became a negative 5x and a positive 4x so that we could factor by grouping. Let's look at the first two terms. 5x squared minus 5x. I can divide out a 5x. I'm left with 5x x minus 1, right? 5x squared divided by 5x is x. Negative 5x divided by 5x is just a negative 1. Over here, I have positive 4x divided by 4, or sorry, minus 4. I'm going to divide them both by 4. 4x divided by 4 is just x. Negative 4 divided by 4 is a negative 1. So here I have x minus 1 times the quantity 5x plus 4. So I've factored the top and bottom of that first fraction. Good. All right, let's look at 15x squared plus 12x. 15x squared plus 12x. So this is not a perfect square. This is not the difference of two perfect squares, the difference of two perfect cubes, the sum of two perfect cubes. So all I can do is see if I have a greatest common factor that I can divide out of both 15x squared and 12x. I think I can think of one because they both have an x, right? 15 and 12, you can divide them both by 3. So I'm going to divide out a 3x. 15 divided by 3 is 5. X squared divided by x is x. 12 divided by 3 is 4. And there's no x because each had an x, so that x will cancel. Good. So for 15x squared plus 12x, I'm just going to call it 3x times 5x plus 4. Good. And then the last part, we have -1 minus 4x squared. Let me put that into descending order, right? So -4x squared minus 1. Now I don't want the leading term to be negative, so I'm going to factor out a -1. -4x squared divided by -1 is a positive 4x squared. -1 divided by -1 is a positive 1. Oh, sorry. I wrote that down wrong. It's not a -1. Positive. All right. So we had 1 minus 4x squared. I'm going to put it in order. -4x squared plus 1. I'm going to factor out a -1. -4x squared divided by -1 is a positive 4x squared. Positive 1 divided by -1 is going to be a -1. Good. We are not done. So when you see a binomial like this, I want you to think, can I make this into the difference of two squares? 4x squared minus 1. Think about this. All right. Can I take 4x squared and take the square root of it and get a term? Yes. If I take 4x squared and I take the square root of 4 is 2, the square root of x squared is x. Right? B squared, is that a perfect square? The square root of 1 is 1. So we can say, oops, sorry, that should be a minus. So I took this, I saw that 4x squared is a perfect square. The square root of 4x squared is 2x. The square root of 1 is 1. So I can take those two perfect squares and say it's a plus b, a minus b. That now goes right here. We have that -1 that we factored out, and then we're going to say 2x plus 1 times 2x minus 1. Good. So before we multiplied, we factored out each part. Okay. Now we put them all into one line. And here we've got it all in that original order. So we simplified that term to get this, 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 right? Now it's just one big fraction. So you've still got a line, a fraction line right here. And now you just want to look, is there any term that is common to the top and the bottom? Like this 5x plus 4 and this 5x plus 4. You can cancel those. This 2x plus 1, this 2x plus 1, you can cancel those. Those are the terms we are able to cancel, and you just collect the rest. I'm going to start with the monomial on top, put it in front of the 5x minus 4. On the bottom, I've got -1 times x plus 1 times 2x minus 1. This -1, you can leave it on the bottom, or you can just say all of this becomes negative. Either of those is correct for number 12. Good. All right, after number 12, we're going to move on to dividing rational expressions. So that was multiplying. Now we're going to divide fractions. When you're dividing fractions, the rule is invert and multiply. So A divided by B divided by C divided by D is equal to A divided by B times D divided by C. I think of it as KFC. So we keep the first term, flip the second term, and change the sign. So we keep the first term, keep A times A divided by B the same, flip that second term. Instead of C divided by D, we now have D divided by C. And change from division to multiplication, KFC. Keep, flip, change. Okay? Do that before you start simplifying. So for number 14, let's just keep, flip, change it. Keep x plus 8 times 1x plus 1 over 3x. Flip. So now that's 12x to the 7th, which was on the bottom, is now at the top. 4x plus 32 was on the top, now it's on the bottom. We flipped it. Now we change from division to multiplication. Now this is just exactly the same as down here. Okay? Keep, flip, change. Kept it. We flipped it. And we changed the sign. Kept it, flipped it, changed the sign. So we're going to do that, and then we are going to simplify. This is already in its factored form, so that's good. Can we factor this? We cannot, because it's only a single monomial. Can't factor a monomial. 4x plus 32. I think we could divide both of those by 4, right? If I take 4x plus 32, and I divided them both by 4, 4x divided by 4 is just x, and then 32 divided by 4 is... So I'm going to change 4x plus 32 to 4 times the quantity x plus 8. So that's the only way I could simplify it before I combine them. I'm going to rewrite that over here. All right, so here it is. We factored as much as we could. Now we're going to combine it. So just straight across. Now we have 12x to the 7th, because that's the monomial, times, is all that, times x plus 8, times the quantity x plus 1, divided by 3x times 4 times 8 plus x. What can we cancel? You can cancel out the 8 plus x plus 8, right? Now look at this. We have x plus 1. There's no more binomials on the bottom, so we know that that's staying in the top. But we have 3 times x times 4. And over here we have 12, right? So if I was to put this into its prime factorization, or if you see something else you can do, that's fine too. But if I was going to put 12 into prime factorization, what's the factor tree of 12? 6 and 2. 6 becomes 3 times 2. So 6 is 3 times 2 times 2, right? 12 is 3 times 2 times 2 in its prime factored form. So instead of 12x to the 7th, I'm going to say it's 3 times 2 times 2 times 7x's, right? On the bottom, what's the prime factorization of 3? It's just 3. What's the prime factorization of 4? It's 2 times 2. And then how many x's do we have on the bottom? We have 1x. And then what do we still have up here? Times x plus 1. Now, can you factor anything out? Yeah. The 3, the 2, and 1 of the x's, right? So we are left with, on the top, instead of 12x to the 7th, we have 1, 2, 3, 4, 5, 6, x to the 6th times x plus 1 that was left over from there, right? So that 12x to the 7th became all of that. The 3x was right here. The 4 was right here. 3x was right here. 4 was right here. There's nothing else on the bottom. If there's nothing on the bottom, you don't put 0, you just put 1, or you can just say anything divided by 1 is itself. So my final answer is x to the 6th times x plus 1. For number 14. Good. All right, number 15, we're going to do the same. Number 15 looks like this: y minus 2 quantity squared divided by 7 divided by 7y minus 14 over 49. Keep, flip, so that's now 49 over 7y minus 14. Change from division to multiplication. Good. All right, let's see if we can simplify this any further. Y minus 2 quantity squared means we're going to write y minus 2 times y minus 2, right? It's not just y squared minus 4. It's the whole thing multiplied by itself. Divided by 7, you can't simplify 7, times 49. The prime factorization of 49 is 7 times 7. And 7y minus 14, I can divide that by 7. 7y divided by 7 just gives me y. Negative 14 divided by 7 is a minus 2. So now that's the factored form. That factors to that. That doesn't change because you can't factor it. 49, if we were to make a factor tree of the number 49, the only factors are 7 times 7 besides 49 times 1. 7y minus 14. I can divide both of those by 7. So I put the 7 out in front. 7y divided by 7 just leaves me with y. Negative 14 divided by 7 just leaves me with negative 2. Good. So I'll write that out again. All together, y minus 2 times y minus 2. I have 7 times 7. I'll put that out in front because they're single terms. Down here, I've got the number 7. Here, I've got another 7. And I've got a y minus 2. Anything common to both the top and the bottom, you can cancel. Cancel the 7, cancel the 7, cancel the y minus 2. Final answer is y minus 2 for 15. Number 16, r squared minus s squared divided by r minus s divided by r squared plus r s. All right, so what I've done is I've kept the first one, kept it the same, flipped the second one, changed the middle term, the middle sign, changed the sign from division to multiplication. All right, let's see if we can simplify it. There's nothing that I can factor out of r squared minus s squared. Nothing I can factor out of r minus s. Nothing I can, oh, yes, there is. All right, so there's nothing I can factor out. There's no greatest common factor for this first one. R squared minus s squared, but remember, a squared minus b squared equals a plus b times a minus b, right? So we can say that r squared minus s squared equals r plus s times r minus s. So that's what we're going to do right there. For r squared minus rs, I said there's nothing we can factor out, but there is. So r squared plus rs, I can factor out an r. When I factor out an r from r squared, I get r. When I factor out an r from rs, I get s. I should put a plus sign between them. Good. So that one's going to be right there. That one we can't factor. That's just a monomial. That one we can't factor because there's nothing common to both r and negative s. So this I'm going to rewrite as r plus s times r minus a. R plus s times r minus s times, what was that one? R times r plus s. You put, just make sure to denote that it's being multiplied. And then the bottom, we've got r minus s times r. Now you just simplify if possible, right? That's common to the top and the bottom. That's common to the top and the bottom. So what we are left with is r plus s times r plus s, which you can simplify to r plus s squared if you want. All right, now we're just going to work on adding and subtracting fractions. So remember, for adding and subtracting any fraction, if the denominators are the same, you just leave the denominator the same and add the numerators together, okay? Check if the expression can be simplified. If you have unlike denominators, find the least common denominator, convert each expression to the least common denominator by multiplying the top and the bottom by the missing factors needed to make the least common denominator. And if you have denominators, proceed with the beginning, right? Because now you have like denominators. 18. Perform the indicated operation. Do you have like denominators? Are these exactly the same? They are. So what do? Keep the denominator the same. They both have m plus 3, so the answer is going to have m plus 3. Add or subtract the numerators. 3 plus m. Now we have 3 plus m on top, divided by m plus 3. Put that into descending order, m plus 3. M plus 3 divided by m plus 3 just gives me 1. Because that is divisible by that. You can cancel it, right? So you just get 1. Here, are the denominators the same? X minus 3, they are the same. So we're just going to subtract 3x minus 9, leave the denominator the same, x minus 3. We are not done because I see at the top you can divide out a 3. 3 is common to 3x minus 9. 3x divided by 3 is x. Negative 9 divided by 3 is a negative 3. Now I see that's common to both the top and the bottom, and I just get the answer of 3 for number 19. Good? All right, number 20 is a tough one. We need to find a least common denominator between the terms 6x and 7x minus 1. There is not anything common to these two, right? The only thing that would be common to that would cancel out both x and x minus 1 would be the term x times x minus 1, right? So the LCD here is x times x minus 1. You just took both of them and multiplied them by each other and got the denominator. Now, what would I do to apply the least common denominator? Here, if I need to get it to x times x minus 1, I have the x. I would multiply both top and the bottom by x minus 1. Right? So then at the top I have 6x minus 1 times x minus 1. For the second term, I just need to multiply them both by x. And it would be 7x times x minus 1. So that's what we mean by least common denominator. Something that will make your denominators the same. Least just means use 2 instead of 8 if you can, right? Use the smallest term you can. So our least common denominator is x minus 1 times quantity x. 3 divided by 4 and 5. Remember, you can turn it into a fraction by putting it over 1. So what would be the least common denominator of 3/4 and 5/1? The LCD is going to be 4. How do we apply it? 3/4, it's already 4, so you don't need to multiply by anything. It'll just be 3/4. And for 5 times 1, you just multiply both the top and the bottom by 4. 5 times 4 becomes 20/4. And this is true because 20/4 is the same as 5, and 5/1 is also the same as 5. Okay, so here it says perform the indicated operation and simplify if possible. So this finding the LCD was practice for performing an indicated operation, even if the fractions don't quite match, right? If the fractions don't match, we're going to make them match. Here we have 4. Remember, if I want to turn it into a fraction to interact with other fractions, I just put it over 1. 4/1 plus 1/7x. What would be the least common denominator? Between 1 and 7x, it's going to be 7x. What do we need to do? 4/1 plus 1/7x. I need to change that 1 to a 7x, so I'm going to multiply it by 7x. Anything I do to the bottom of the fraction, I have to do to the top of the fraction. So that becomes 4 times 7x is 28. 28x over 7x plus, and that just remains the same, 1/7x. Remember, you're leaving the bottom the same. They have the same denominators, and then you add or subtract the numerators. So now it's 28x plus 1. And you were finished because 28x and 1 are not common terms, so you can't combine them. Good. 23, this is our last one. 7 divided by x plus 5 minus 6. Remember, you can turn 6 into 6/1. So we've got We've got 7 divided by x plus 5 minus 6 divided by 1. My least common denominator is going to be x plus 5. This already has x plus 5, so it's just going to remain as 7 times x plus 5 divided by x plus 5 minus 6/1. How to get 1 into x plus 5? Multiply it by x plus 5. Anything I do to the bottom, I have to do to the top. Right? 1 times x plus 5 just leaves us with x plus 5. Now I'm going to combine the top, leave the denominator the same. 7 minus 6 times x plus 5 divided by x plus 5. Now, I'm not just gonna take 7 minus 6 equals 1, right? I can't do that. But if I want to keep simplifying, well, okay, I can't take 7 minus 6, right? I can't just say it's 1 times x plus 5. I can't cancel the x plus 5 and the x plus 5 because of this minus sign, right? So way over here when we were canceling, because we had common terms, it's because everything was being multiplied, right? But here we have 7 minus 6. So we can't just cancel that. We can't say 7 minus 6 x plus 5. But we can say we're going to distribute the 6, the negative 6 to the x and to the positive 5. So now we have 7, negative 6 times x is minus 6x. Negative 6 times positive 5 is a minus 30 over x plus 5. Now, combine like terms. Negative 6x plus 7 minus 30 and final answer. because 7 minus 30 is a negative 23, so it's just negative 6x minus 23 over x plus 5. All right, guys, that is all for the rational expressions. Thank you and have a great day. See you next time.